This is problem 132 of Neetcode 150, non-overlapping intervals. So in this problem, we are going to be given an array of intervals. And inside this array, at every position, we have a starting value and an ending value, which represents a particular interval. We will have some overlapping intervals inside our interval, so inside the input we're given. And in this problem, Um, by contrast to the other interval problems we've seen previously in Neetcode 150, um, if the if the second value of a particular interval is equal to the first value of the other interval, these are considered non-overlapping. So for example, here if I have 1, 2, and then 2, 3, in the previous example, this will have been something considered as overlapping. But in this case, it is not. So what will be something that is overlapping? It will be 1, 3, and 2, 4 because 2 is strictly in the middle of 1 and 3. Okay? So what is our task? Our task is to basically tell what is the minimum amount of interval we can remove to have basically a list of non overlapping intervals. So for example, in this example 1, if we remove the 1 and the 1, 4, we're going to end up having 1, 2, and 2, 4, which is not considered as an overlap in this problem, and that will work. So the output is 1. In example 3, we have 1, 2, and 2, and 4. No overlap here, so the output is 0. Let's go on a whiteboard and see how we're going to solve this. So I will use a greedy approach, and I will basically start by sorting my arrays by the first value. Okay, so the first thing I want to do is that I will create an ending index, and the ending index will initially be set to the second entry inside the very first interval that we have. This is just to tell us that starting from this 1, we're gonna have to go up to 7. Okay, so this is the ending value of 7. And if, for example, after this we add another array that was like 7 to 9, well, or that will be okay. So we will not have to increment the big red R here that stands for how many intervals do we have to remove. We will not have to add 1 to this because this will basically be something that matches. And then our new and will be 9. All right. But now this is not exactly our case. So what we're going to do is basically that we're initially going to set this ending array to be, this ending value to be 7. And then we're going to scratch this. And we're going to go basically see all the other intervals in our set. And the logic is that we are going to add 1 to the remove if the starting value of the next interval inside our sorted intervals is smaller than the end. Right now it is smaller. So what we're going to do is that we are going to add 1 to R. So we know that we're going to have to remove 1 interval at least. And then which interval do we want to remove? Well, this is going to affect the ending array, right? At the ending value. Because if we remove the 1, 7, well, the ending will now be 3, right? But if we remove the 1, 3, the ending will be 7. So in order to be efficient, we're just going to take the minimum value here. So we're going to go for a 3. Because what we risk to do if we take the 7 is that we basically take the place of other intervals. Right? So by removing it, we just reduce the possibility of having another overlap. So now we did our 1, 3. I'm going to scratch this in another color. Let me pick red. So now we're going to go see 3, 4. We see that it starts with a 3. Since it starts with a 3 and it is equal to the n, right? As long as it is equal or greater than the n, it is fine. What we're going to do is that we're just going to change this to the actual n of this particular interval, which is 4. So now the n will be at 4, and that's it. Now we're going to go see the other intervals, but there are no other intervals. So we are just going to return the R value, which is the amount of value we the amount of intervals we have to remove to have a set of non-overlapping intervals. So this is going to be the answer. This is going to be 1. That's a greedy approach. It's going to use basically a time complexity of big O n log n. Reason is that I will basically sort the array at first, because that's just the most efficient way to do it. Otherwise, it will be quite complicated. So the sorting operation itself is going to be the longest time complexity. So it's going to be big O of log n log n, and the space complexity, well, it's going to be big O of 1, or it can be big O of n depending on the sorting algorithm, but we will generally say it's big O of 1 since we're not storing anything else we're using. We're going to use the dot sort function in Python. So in our code, we're not going to store anything else. So let's go ahead and code this. So the first thing I want to do is going to be to sort the intervals. Great, so this is good. Now I'm going to be willing to create the value n, which is going to be initially set to the first value of this, well, the second entry of the first value of this interval. So it's going to be intervals at the index 0, and I want the second value of this index 0. This is good. And I want to have a variable that will keep track of how many value we have to remove. In my example, it was just big R, right? So let's just keep our big R here, so we are constant. Okay. And now I will go for basically all the other intervals. So I'll say for start and in intervals, and I'm gonna skip the first index as we already computed it. Okay, and I'm also retrieving the starting and ending index. Great, so now what I want to check first is basically if the end value is equal or greater. Well, I want to see if the start is equal or greater than the end value. If it is equal or greater, it means that we just have another interval that does not overlap with the previous one. So we're just going to set the n to be equal to the n of that particular interval. And that really is everything we need to do in this case. If it is not greater or equal to the n, it means that there is an overlap. So what we're going to do is that we are just going to increment the big R by 1. And we're going to set the n to be equal to the minimum value between what it currently is and the n that we could potentially have if we use the other numbers, right? And that's it. So we can now return big R, and that's gonna give us the answer. So yeah, that works. Awesome. I hope you enjoyed the video, and I hope to see you in the next one.